Hi, this is Beverly, and this is a presentation of my final project, which is on Impala. So what is Impala? Impala is a real-time big data query capability. It's massively parallel, allows you to do SQL queries, and runs on Apache Hadoop. Impala gives you query speed that's fast enough for interactive use. Normally, MapReduce jobs have a significant startup time, which makes them too slow for an application which requires real-time response to your users. So some corporate information. Impala is a Cloudera project. It is Apache licensed open source software. If you want, there's an enterprise version for production support. Some of the benefits of Impala are that it executes query without a need for moving your data in and out of HDFS or transforming it. It supports a diversity of unstructured data formats as opposed to RDBMS tables, which require you to set up what your tables look like and not change them. Because it supports standard SQL interfaces, it allows existing BI tools to interface with the data that's stored in HDFS or HBase. And it's also significantly faster than Apache Hive or Stinger, approximately 10 to 100 times faster. So some more benefits are that it uses the same metadata, ODBC, and SQL syntax as Hive. So if you have applications that are built on Hive, you can port those over to Impala without making changes to your code, at least only insignificant changes. So with Impala, you can do SQL queries on trillions of rows of data, which is more than you can do in a typical RDBMS database. And also you can do join clauses, which is not something that's supported by all SQL engines running on big data. So some drawbacks of Impala is it does not support all the SQL capabilities that Hive does. For example, certain aggregating statistical functions, like for example variance, that are supported by HiveQL are not supported by Impala. Also, XML and JSON functions are not supported by Impala. It also has a limitation that when you do order by clauses, you also have to include a limit clause, which means it's going to reduce the number of returns. It also does not support update SQL, and that's because it's not a transactional database. It's more geared towards bulk updates. Part of what's special about the Impala architecture is it actually does not use MapReduce to access the data. And that's how it's able to get that real-time query capability. What it does is it has its own architecture that accesses the data as it resides in HBase or HDFS without going through MapReduce. So if you want to install Impala, the easiest way to get started is to download the Cloudera Quick Start VM. Impala is installed on that by default. As I've said before, it does not have a dependency on MapReduce, so if you're putting it in installing from scratch, you don't have to install MapReduce. You do have to have at least a 64-bit OS and 8 megabytes of RAM. Actually, that should be gigabytes. So to get started, I suggest you do what I did and download the Cloudera 5.0 VM, which includes Impala 1.30. So what I did as a project for Impala is I downloaded two different data sets. One was census data from 2010, and I created a table in Impala that includes all that information. So it has census data rolled up by zip code, and it has like the population in that zip code, the population that's male, female, households of single mothers, single fathers, households with older folks and younger folks, and more folks and less folks. One thing to notice about this create table statement is the external keyword there. What that does is it tells the create table the table structure actually looks at the data as it resides in HDFS. So if you see at the bottom of that create table statement it says location and then it gives a path, that's actually a path to the location of the data in HDFS. And the row before that, where it says row format delimited fields, that actually describes the format of the data as it resides in HDFS. For example, I uploaded a CSV, so comma separated file, and that row right there describes that format. So secondly, I also found a zip code table so that I could do a join between my census data and get more description of where those zip codes are. Like it tells me, for example, the city and the state and the county in which the zip codes are. So that's my create external table statement for the zip code table. So when I started doing joins, I encountered some issues with performance with Impala, which required me to do a little research. One thing I found is that if you want to do any significant things in Impala, you need to do compute stats on your tables, which allows it to count the number of rows, etc., to optimize your queries. I did find that on the zip code table it did not do very well with that compute stats function, and I tracked that down to a bug where it does not compute very efficiently on a single processor machine. Through just a little monkeying around, what I've found is that if you delete a lot of your string fields, then that gets around the problem. So that's just what I did. I deleted the, like for example, the acceptable, unacceptable, time zone fields, just kind of minimize the data in my table, and then it was able to compute stats just fine. So this is the output of some queries that I got running in Impala with those two data sets. First of all, I asked myself, okay, so what are the most populated zip codes in the United States? So on the right there, that's the SQL query to get at that answer. You see it's using a where clause to join the two tables, and then it does order by population, descending, and gets me the top 10 most populated zip codes. And I, in the inverse, did the same thing for the least populated zip codes in the United States. And it pulled back a few that were zero, so I excluded those as well. So getting to some slightly more complicated SQL statements using my two data sets, I then did some roll-up and asked myself, okay, so what are the most populated states and the least populated states? To get at that, I had to group by my states. So it rolled up all the zip codes that are in the state and summed it up. So you see that sum aggregation function in my SQL statement. And then again, ordering by that aggregate of the population in each state. And so finally, I asked it a slightly even more complicated question, and that are these two things. So what are the states with the highest percentage of single mother households? To do that, I had to get slightly more complicated with my SQL statement, and you see that I'm actually doing some math there in my select clause where I'd sum the total population, total number of households that have single mothers, and then I divide it by the sum of all households. So that gives me a percentage, and then I have to do the exact same thing in the order by clause to order by that amount. And similarly, I did the same thing to determine what are the states that have the highest percentage of individuals who are 60 or plus years old. And interestingly, the answer to that was Hawaii, which I wouldn't have guessed, and Florida, which I would have guessed, and PR, which I believe is Puerto Rico. And that is all I have. Thank you for sitting through my introduction to Impala.